The birth and evolution of the universe, a calm journey through cosmic time. Before we begin tonight's journey, if you find these slow explorations through space relaxing, you can gently support the channel by leaving a like or subscribing for more quiet documentaries like this one. It truly helps this space continue to grow. And now, there is nothing else you need to do. Just settle in, breathe slowly, and allow the universe to unfold at its own peaceful pace. Tonight, we are going to travel farther than any human has ever gone. Far beyond planets, beyond stars, beyond even galaxies. We are going to slowly trace the story of the universe itself, from its quiet beginning to its vast and silent present. There is no rush. The universe has taken billions of years to unfold. We can take our time as well. Around 13.8 billion years ago, everything that exists today was compressed into a state of extraordinary density and temperature. There were no stars, no light in the way we understand it, and no space stretching in every direction. Instead, space itself had yet to fully emerge. What we call the Big Bang was not an explosion in space. It was the expansion of space. Every point expanded simultaneously, carrying energy outward in all directions. In the first fraction of a second, the universe expanded incredibly fast in a period scientists call inflation. During this brief moment, the cosmos grew from subatomic scales to something much larger, smoothing itself out and setting the stage for everything that followed. Even now, faint echoes of that early moment can still be detected as background radiation that softly fills the universe. As the expansion continued, the universe began to cool. Within the first few minutes, the simplest atomic nuclei began to form. Hydrogen and helium emerged as the primary building blocks. For hundreds of thousands of years after that, the universe remained a hot, dense fog of charged particles. Light could not travel freely yet. The cosmos was opaque, glowing softly but without structure. Then, around 380,000 years after the beginning, something profound happened. The universe cooled enough for electrons to combine with nuclei, forming neutral atoms. Suddenly, light was able to travel without constant scattering. The universe became transparent. That ancient light is still detectable today as the cosmic microwave background, a faint afterglow that surrounds us in every direction, a soft whisper from the earliest chapter of time. After this moment, the universe entered what is sometimes called the cosmic dark ages. There were no stars yet. No galaxies. Only vast clouds of hydrogen and helium drifting slowly through expanding space. Gravity, however, was quietly at work. Over millions of years, slight variations in density began pulling matter together. Regions that were only slightly denser than their surroundings slowly attracted more and more material. Eventually, these growing clouds became dense enough to ignite nuclear fusion. The first stars were born. These early stars were massive, much larger than most stars we see today. They burned hot and bright, forging heavier elements in their cores. When they reached the end of their relatively short lives, they exploded in powerful supernovae, scattering newly formed elements into space. Those ancient explosions enriched the surrounding cosmos with carbon, oxygen, silicon, and iron. The universe was no longer composed of only hydrogen and helium. It had become more complex. The ashes of the first stars became the seeds of future generations, forming new stellar systems across the expanding darkness. As more stars formed, gravity began organizing them into vast rotating structures. Galaxies emerged. Some were small and irregular, while others grew massive, spiraling gracefully through space. Our own Milky Way began forming more than 13 billion years ago, gradually accumulating stars, gas, and dark matter into the structure we recognize today. Dark matter, though invisible, played a crucial role in shaping the universe. It does not emit or reflect light, but its gravitational influence is undeniable. Without dark matter, galaxies would not have formed in the way they did. It acts as a hidden framework, holding cosmic structures together and guiding the formation of clusters and superclusters. At the centers of most galaxies, including our own, lie supermassive black holes. These regions are not empty voids but concentrations of mass so dense that gravity becomes overwhelming. Beyond a boundary called the event horizon, nothing can return. Yet black holes are not violent destroyers in constant motion. They sit quietly at galactic centers, influencing nearby stars through gravity while space flows calmly around them. Over billions of years, galaxies continued to drift and merge. When two galaxies encounter one another, their stars rarely collide because the distances between them are enormous. Instead, gravity reshapes both systems over long timescales, often triggering waves of new star formation. The cosmos is dynamic, but its changes unfold gradually, almost gently, across unimaginable expanses of time. About 4.6 billion years ago, within a spiral arm of the Milky Way, a cloud of gas and dust began collapsing under its own gravity. At the center of that collapse, temperatures rose until nuclear fusion ignited. Our sun was born. Around it, the remaining material flattened into a rotating disk. Within this disk, particles collided and stuck together, slowly forming planetesimals and eventually the planets. Earth formed approximately 4.5 billion years ago. At first, it was a world of fire and impacts. Volcanoes reshaped its surface. Asteroids struck its crust. Over time, it cooled. Water condensed from vapor into oceans. In those oceans, complex chemistry gradually gave rise to life. Simple organisms evolved slowly, adapting to their environment over billions of years. While life on Earth unfolded in quiet stages, the broader universe continued expanding. Galaxies moved farther apart. Space itself stretched continuously. In the late 20th century, astronomers discovered that this expansion is accelerating. Something unknown, referred to as dark energy, appears to drive galaxies apart at an increasing rate. Dark energy remains one of the great mysteries of modern science. It constitutes most of the universe's total energy content. Dark matter adds another large portion. The atoms that make up stars, planets, and every living being account for only a small fraction of what exists. Much of the cosmos remains unseen, understood only through its gravitational effects. As time passes, star formation gradually declines. Galaxies consume their supply of cold gas. Massive stars live quickly and end dramatically, while smaller stars burn slowly for trillions of years. Red dwarfs, the most common stars in the universe, may shine long after larger stars have faded. Far in the future, the universe may enter an era of deep darkness. Most stars will have exhausted their fuel. White dwarfs, neutron stars, and black holes will remain. Even black holes may slowly evaporate over vast timescales through quantum processes, releasing faint radiation into the expanding void. If cosmic expansion continues accelerating, distant galaxies will eventually slip beyond our observable horizon. Light emitted from them will never reach us. Future observers might see only their local galaxy, unaware that countless others once filled the night sky. Yet tonight, none of that urgency applies. The universe moves patiently. It unfolds over billions and trillions of years. Stars form. Stars fade. Galaxies rotate slowly in the darkness. The cosmic microwave background still drifts through space, unchanged for nearly 14 billion years. The atoms within you were forged in ancient stars. The carbon in your cells, the oxygen in your lungs, the calcium in your bones, all were created in stellar furnaces long before our solar system existed. In a very real sense, you are made of stardust, assembled during a brief but meaningful moment in cosmic history. When you look at the night sky, you are looking back in time. The light from distant stars began traveling long before human civilization. Some galaxies we observe no longer exist in their original form. Their light is simply arriving now, completing a journey that began billions of years ago. The universe continues its quiet expansion. Galaxies drift. Clusters stretch along delicate cosmic filaments. Gravity shapes motion with calm precision. On cosmic scales, everything unfolds gradually, without haste. Imagine drifting beyond the edge of the Milky Way, looking back at its spiral arms glowing softly. Beyond it, countless galaxies shimmer faintly against the darkness. There is no sound, no wind, no friction, only the steady rhythm of physics guiding matter through space. The universe does not strain. It does not rush. It expands smoothly, following laws established in its earliest moments. And tonight, as you rest, stars continue shining in distant galaxies. Nebulae slowly collapse into new suns. Black holes sit at quiet centers. Photons travel across immense distances, carrying stories from the past. You are part of this immense unfolding. A brief chapter, yet connected to every other. There is nothing you need to accelerate. Nothing you need to control. The cosmos has taken nearly 14 billion years to reach this moment. It can carry on calmly. And so can you. Allow the vastness to feel steady rather than overwhelming. Allow the darkness to feel quiet rather than empty. Above you, the universe continues its patient expansion. And here, on this small world orbiting a modest star, you can simply rest beneath it. The cosmos will continue its journey. Slowly. Silently. Endlessly. And for now, you can drift, knowing you are carried within it. Beyond the visible stars of our galaxy lies something even more vast. The Milky Way is only one member of what astronomers call the local group, a small gravitational community of more than 50 galaxies. Most of these are dwarf galaxies, faint and irregular, gently orbiting larger companions. The largest among them is the Andromeda Galaxy, a spiral system slightly bigger than our own. Andromeda is drifting toward us at a slow but steady pace. Not because space is collapsing, but because gravity binds our local group together despite the expansion of the universe. In about 4 billion years, the Milky Way and Andromeda will begin a gradual merger. Their spiral arms will stretch and distort, forming long arcs of stars. Over hundreds of millions of years, the two galaxies will blend into a single, larger system. It will not be a violent collision in the way we imagine impacts on Earth. The distances between stars are so vast that direct stellar collisions are extremely unlikely. Instead, gravity will slowly reshape the orbits of billions of stars, including our Sun. By that distant time, Earth itself may no longer be habitable. Our Sun, like all stars, follows a life cycle determined by its mass. It currently rests in a stable phase known as the main sequence, steadily converting hydrogen into helium through nuclear fusion. This process produces the light and warmth that sustain life on Earth. But fusion gradually changes the composition of the Sun's core. As hydrogen becomes depleted, the balance between gravity and outward pressure will shift. In roughly 5 billion years, the Sun will begin to expand into a red giant. Its outer layers will swell outward, potentially engulfing the inner planets. Even before that moment, Earth's oceans will likely evaporate as solar luminosity increases. Yet this transformation will unfold slowly on cosmic timescales. There will be no sudden flash. Only gradual change, measured across millions of years. Stars more massive than the Sun experience far more dramatic endings. When they exhaust their nuclear fuel, their cores collapse rapidly, triggering supernova explosions. In those final moments, temperatures rise to extreme levels, forging elements heavier than iron. Gold, uranium, and many other rare elements are born in these explosive events. The debris from supernovae spreads outward, enriching the interstellar medium and preparing the material for future generations of stars. Some collapsing cores become neutron stars, incredibly dense objects where matter is compressed so tightly that a teaspoon would weigh billions of tons. Others collapse even further, forming black holes. Black holes vary in size, from stellar remnants only a few times the mass of the Sun to supermassive giants containing billions of solar masses. Despite their dramatic reputation, black holes are governed by simple physical laws. Their event horizons mark boundaries beyond which escape is impossible. Yet from a distance, they behave much like any other massive object. Planets could theoretically orbit a black hole if it replaced the Sun, though there would be no warmth or light to sustain life. Surrounding many black holes are swirling disks of superheated matter. As gas spirals inward, it releases immense energy, sometimes outshining entire galaxies. These energetic centers are known as quasars. They were far more common in the early universe when galaxies were rich in gas and black holes were actively feeding. Today, most supermassive black holes sit quietly, including the one at the center of our own galaxy. Zooming outward even farther, we find galaxy clusters, massive collections of hundreds or thousands of galaxies bound together by gravity. These clusters connect through long filaments of dark matter and gas, forming what scientists call the cosmic web. On the largest scales, the universe resembles a vast three-dimensional network, with dense clusters linked by delicate strands and separated by enormous voids. These voids are not completely empty. They contain sparse gas and occasional galaxies, but compared to clusters, they are regions of remarkable emptiness. Light crossing a cosmic void may travel for hundreds of millions of years without passing near a galaxy. The universe is structured, yet also profoundly spacious. As we consider these enormous patterns, it becomes clear that the universe evolved from simplicity to complexity. From a nearly uniform sea of particles emerged galaxies, stars, planets, and eventually conscious observers capable of reflecting upon their origins. The laws that governed the first seconds after the Big Bang still govern the motion of galaxies today. Time in the universe flows steadily forward. Entropy increases. Systems move from order toward disorder. Stars convert organized nuclear fuel into dispersed radiation. Black holes slowly radiate energy over unimaginable durations. The cosmos trends toward equilibrium, though the journey will take trillions upon trillions of years. If expansion continues accelerating under the influence of dark energy, distant galaxies will eventually fade beyond view. The observable universe will shrink relative to any one location. Civilizations existing far in the future may not have access to evidence of the Big Bang or distant cosmic structure. Their night skies could appear quiet and nearly empty. Yet in our era, we are fortunate to observe a rich and detailed cosmos. Advanced telescopes allow us to detect galaxies whose light began traveling when the universe was only a few 100 million years old. We see stellar nurseries glowing within dark nebulae. We measure the faint temperature variations in the cosmic microwave background, mapping the infant universe with extraordinary precision. Each observation refines our understanding, yet many mysteries remain. We do not fully understand the nature of dark matter. We do not know what dark energy truly is. We cannot yet reconcile quantum mechanics with gravity in a complete theory of everything. The universe still holds questions that may take generations to unravel. And yet, despite those mysteries, its overall story unfolds with remarkable clarity. Expansion, cooling, structure formation, star birth, element synthesis, planet formation, gradual evolution. Across billions of years, gravity gently sculpts matter. Nuclear fusion shines steadily within stellar cores. Space continues stretching quietly in every direction. From a distant perspective, Earth is a thin layer of life on a small rocky world orbiting a modest star. That star resides in a spiral arm, itself one among hundreds of billions within our galaxy. Our galaxy is one among trillions within the observable universe. Such scale can feel immense. But it can also feel grounding. Because everything follows patterns. Physical laws apply consistently across space and time. The same forces that shaped the first hydrogen atoms guide the motion of galaxies today. Imagine drifting through intergalactic space. No sound. No atmosphere. Only faint starlight from distant systems. The darkness is not threatening. It is simply vast. Within it, galaxies rotate slowly, each containing billions of suns. Nebulae glow softly when new stars are forming. Old stars fade gently into compact remnants. Even now, somewhere in the cosmos, a new planetary system is taking shape from a collapsing cloud of gas and dust. Somewhere else, a star is reaching the end of its fuel, expanding outward in its final luminous phase. And in another distant region, light emitted billions of years ago is just now arriving at an observer's telescope. All of this unfolds without urgency. The universe does not hurry. Its processes span millions and billions of years. Change is constant, but it is almost imperceptible in any single moment. As we approach the farthest projections of cosmic time, models suggest several possible futures. The most widely supported is continued expansion leading to a gradual heat death. In this scenario, stars burn out, matter decays, and the universe approaches a state of near uniform temperature and maximum entropy. It would not end in fire or collapse, but in cooling silence. Other hypotheses have been proposed. Some suggest cycles of expansion and contraction. Others propose quantum transitions to new states. These ideas remain speculative. For now, evidence indicates a steady outward acceleration. Yet regardless of distant possibilities, the present remains stable and calm. Our cosmic era is one of structure and light. Stars are abundant. Galaxies are visible. Complexity thrives. The atoms in your body were once scattered across interstellar space. They traveled within ancient stellar winds and supernova remnants before becoming part of a molecular cloud that eventually formed the Sun and its planets. Over billions of years, those atoms reorganized into living systems capable of awareness. In that sense, the universe has become conscious of itself through its structures. Matter arranged itself into patterns that can reflect, observe, and wonder. And yet, despite the complexity, the broader cosmos remains simple in its motion. Expansion continues. Gravity binds. Fusion shines. Radiation travels. Above you, tonight, the same stars that guided ancient civilizations continue their slow arcs across the sky. Their light has traveled through space almost undisturbed. Each photon follows a path determined long ago. There is a steadiness in that motion, a reliability in the laws that govern it. And as the universe carries on with quiet persistence, you can mirror that same calm rhythm. There is no need to match cosmic scale with thought. No need to grasp every distance or time span. Simply recognizing that you are part of this immense continuity is enough. From the earliest expansion to the farthest projection into darkness, the universe unfolds without hurry. It expands. It cools. It forms stars. It reshapes galaxies. And it continues. Tonight, while distant quasars glow and galaxies drift farther apart, you remain here on a stable world circling a steady star. The cosmos is vast, yet it is not chaotic. It follows its path. And you can follow yours into rest. There is nothing urgent in intergalactic space. Only slow rotation. Slow expansion. Slow change. Let that pace settle around you. The universe has taken nearly 14 billion years to reach this quiet moment. It will continue for trillions more. And within that immense timeline, this night is gentle and still. The stars remain. The darkness remains. And you can allow yourself to drift peacefully beneath them. The cosmos is patient. And so, for now, you can be patient too. Rest beneath the vastness. Drift within the silence. And let the universe continue expanding, quietly, endlessly, as you fall into sleep. And as the universe continues its patient expansion, there are still deeper layers of its story waiting quietly beyond what we have explored so far. If we move outward in scale once more, beyond individual galaxies and even beyond clusters, we encounter the largest known structures in existence. These immense formations stretch across hundreds of millions of light-years and contain vast concentrations of galaxies bound together within enormous dark matter halos. They are sometimes called superclusters, though modern measurements suggest that many of these groupings are not gravitationally bound in the long term, but are instead regions temporarily shaped by the expansion of space. One of these immense structures contains our own galaxy. It is part of what astronomers call the Laniakea supercluster, a region that spans more than 500 million light-years. Within this vast cosmic neighborhood, galaxies slowly drift along gravitational flows, like leaves floating within an enormous current. Even at this scale, motion is gentle. Nothing rushes. Galaxies do not collide violently on human timescales. Instead, they respond gradually to gravity's pull, reshaping their paths over billions of years. If we zoom out even farther, the observable universe appears almost like a living network. Filaments of galaxies form long, thread-like bridges connecting dense clusters, while enormous voids stretch between them. These voids can span hundreds of millions of light-years and contain very few galaxies. They are among the most silent regions imaginable. A spacecraft traveling through one of these voids might drift for millions of years without passing near a single star system. Despite this immense scale, the observable universe is only a portion of what exists. Because space has been expanding since the beginning, and because light travels at a finite speed, we can only observe regions whose light has had enough time to reach us. Beyond that horizon lies more universe, possibly infinitely more. The cosmos may extend far beyond what we will ever see. The idea of infinity can feel abstract. Yet in cosmology, it is a serious consideration. If space is flat on large scales, as current measurements suggest, it may continue indefinitely. In such a scenario, somewhere far beyond our observable horizon, there could be regions where matter has arranged itself in configurations similar to ours. There could be galaxies resembling the Milky Way, orbiting stars resembling our Sun. These possibilities remain speculative, yet they arise naturally from mathematical models. Returning closer to home, we find that even within our own galaxy, much remains undiscovered. The Milky Way contains hundreds of billions of stars. Many of them host planetary systems. Recent surveys suggest that planets may be more common than stars. Rocky worlds, gas giants, icy bodies, all orbit quietly around distant suns. Most will remain unseen by human eyes, yet they exist within the same cosmic web. Some of these distant worlds orbit within what astronomers call habitable zones, regions where liquid water could exist. Whether life emerges elsewhere depends on countless variables: chemistry, stability, energy sources. The universe is vast enough that even rare events may occur frequently somewhere. Meanwhile, stars continue their steady cycles. In dense molecular clouds, gravity compresses gas and dust into protostars. These young stars are often surrounded by swirling disks where new planets form. Jets of material shoot outward from their poles as magnetic fields channel energy into space. Over millions of years, these young systems settle into stability, and a new star joins the countless others shining in the galaxy. Older stars follow quieter paths. Red giants slowly shed their outer layers, creating glowing planetary nebulae. These delicate shells of gas expand outward, illuminated briefly by the fading core within. Eventually, only a white dwarf remains, slowly cooling for trillions of years. White dwarfs are incredibly dense, composed of carbon and oxygen packed tightly together. They no longer generate energy through fusion. Instead, they slowly radiate away their stored heat, fading gradually into darkness. Given enough time, they may become what are sometimes called black dwarfs, cold remnants that emit almost no radiation. However, the universe is not yet old enough for any black dwarfs to exist. Time continues flowing forward, and with it, cosmic evolution persists. On scales even smaller than stars and planets, atomic interactions quietly shape matter. Nuclear forces bind protons and neutrons together. Electromagnetic forces determine how atoms combine into molecules. Even the stability of stars depends on the balance between gravity and nuclear pressure. All of these forces operate consistently, from the smallest scales to the largest. The same physical constants that govern the earliest moments after the Big Bang still govern every process unfolding today. This continuity provides a sense of order within the immensity. If we imagine traveling billions of years into the future, we would witness gradual transformation. Galaxies beyond our local group would slip beyond visibility due to accelerating expansion. The cosmic microwave background would become increasingly redshifted, stretched into wavelengths too long to detect easily. Observational evidence of the universe's early stages might slowly fade. Eventually, star formation would decline significantly. Without fresh supplies of cold gas, galaxies would become populated mostly by aging stars. The night sky, if seen from a planet in that distant era, would contain far fewer bright points. Darkness would deepen. And yet, even in that darkness, physical processes would continue. Brown dwarfs, failed stars too small to sustain fusion, would drift quietly through space. Neutron stars might occasionally merge, emitting bursts of gravitational waves that ripple through spacetime itself. Black holes could merge as well, sending subtle distortions through the cosmic fabric. Gravitational waves are among the most gentle phenomena in the universe. They are ripples in spacetime produced by accelerating masses. When two black holes spiral into one another, they release energy not primarily as light, but as distortions in the geometry of space itself. These waves pass through matter almost undisturbed. When they pass through Earth, they stretch and compress distances by fractions smaller than atomic nuclei. Spacetime itself is dynamic, flexible, responsive to mass and energy. General relativity teaches us that gravity is not a force pulling objects together in the conventional sense. Instead, massive objects curve spacetime, and other objects move along those curves. Planets orbit stars because they follow the curved paths shaped by stellar mass. Even the expansion of the universe is related to the geometry of spacetime. Large-scale curvature and energy distribution determine how space evolves. Observations suggest that the universe is very close to flat, meaning its geometry allows for continued expansion without eventual recollapse. The concept of curvature may seem abstract, but it influences everything from planetary orbits to the trajectory of light traveling across billions of light years. Massive clusters of galaxies can bend light, creating gravitational lenses. These lenses magnify distant galaxies, allowing astronomers to see objects that would otherwise remain invisible. Through such lenses, we observe some of the earliest galaxies ever formed. Their light has traveled for over 13 billion years, stretching into infrared wavelengths as the universe expanded. By studying them, scientists reconstruct how structure emerged from primordial fluctuations. Those primordial fluctuations were tiny variations in density present in the early universe. Their origins may trace back to quantum fluctuations during inflation. Subatomic randomness, amplified by cosmic expansion, eventually became galaxies and clusters. The largest structures in existence may have begun as minute quantum disturbances. This continuity, from quantum scales to galactic scales, illustrates how interconnected the cosmos is. Tiny variations at the smallest levels can influence the distribution of matter across billions of light years. As night deepens and thought slow, it can be comforting to consider that the universe, despite its complexity, operates through understandable principles. Physics describes motion, energy, interaction. The cosmos follows these principles faithfully. Even uncertainty, such as quantum indeterminacy, follows predictable mathematical rules. Particles exhibit probabilities rather than fixed outcomes, yet these probabilities are consistent and measurable. If we continue forward in time far beyond stars and galaxies, the universe may approach thermodynamic equilibrium. Matter decays. Black holes evaporate. Radiation spreads thinly across expanding space. Energy differences diminish. The cosmos cools toward near uniformity. In such a distant epoch, change would occur so slowly that it would seem almost suspended. Trillions upon trillions of years would pass between meaningful events. The universe would become dark, dilute, and quiet. Yet even that distant stillness would not erase the earlier chapters. The universe would carry within it the history of expansion, star formation, and complexity. Every atom would bear the imprint of nuclear reactions long past. Back in the present, we exist in a luminous era. Galaxies shine brightly. New stars are born. Planets orbit stable suns. Life has emerged at least once, perhaps many times across cosmic distances. Humanity's understanding of the universe has evolved rapidly within just a few centuries. From early telescopes revealing moons around Jupiter to modern observatories mapping billions of galaxies, our knowledge has expanded dramatically. Yet compared to cosmic timescales, this advancement is recent and brief. Above us, constellations appear steady, though they slowly shift over thousands of years. The North Star will not remain our guiding marker forever. Stellar motion gradually reshapes the night sky. The Earth rotates steadily beneath those stars. Seasons change predictably. The moon cycles through phases. These rhythms provide stability within an ever-expanding universe. There is something deeply calming about recognizing that, on cosmic scales, nothing urgent is happening tonight. Stars will not burn out suddenly. Galaxies will not collide within a human lifetime. Expansion continues at its measured rate. Light from distant galaxies continues traveling peacefully through space. Gravity continues shaping orbits. Nuclear fusion continues glowing softly within stars. The universe does not demand attention. It unfolds whether observed or not. And as it unfolds, it carries with it quiet continuity. From the first atoms formed after the Big Bang to the complex structures that exist today, each phase builds upon the last. Matter gathers. Energy radiates. Space expands. Time moves forward. These processes are steady, dependable. If you imagine yourself suspended gently above Earth, looking outward into the depths of space, you would see a soft glow of starlight against profound darkness. You would not hear sound. There would be no wind. Only motion following invisible curves. Above, below, and in every direction, space stretches beyond measure. Yet here, on this small world, life continues within a thin protective atmosphere. Oceans move slowly with lunar tides. Forests grow quietly. Clouds drift across the sky. The contrast between cosmic vastness and earthly calm is subtle rather than dramatic. Both operate on their own natural timelines. Somewhere in the universe right now, two galaxies may be merging. Somewhere else, a young star may be igniting for the first time. And somewhere far away, ancient light may be reaching a planet whose inhabitants look up and wonder, just as we do. The cosmos is not still. It is simply slow. And within that slow unfolding, you can find rest. There is no need to traverse its full scale. No need to measure every distance. It is enough to know that the universe expands calmly, guided by forces that have remained consistent for billions of years. Stars shine. Black holes turn silently. Galaxies drift. And space continues stretching outward into quiet infinity. As you settle deeper into stillness, imagine the cosmic web glowing faintly across unimaginable distances. Imagine gravity shaping motion with gentle precision. Imagine photons crossing billions of light years, carrying soft information from the past. The universe has always moved at its own pace. Tonight, you can match that pace. Slow, steady, unhurried. Above you, beyond clouds and atmosphere, beyond the orbit of satellites and the edge of our solar system, the Milky Way rotates quietly. Beyond it, clusters shine faintly. Beyond them, expansion continues. And far beyond what we can see, more universe unfolds. All of it calm. All of it patient. All of it continuing, whether noticed or not. The cosmos does not rush toward its future. It simply becomes. And as it becomes, you can allow yourself to drift within its vastness. There is nothing urgent in the space between galaxies. Only gentle expansion. Only quiet persistence. Only time unfolding. The universe has carried itself for nearly 14 billion years. It will continue for trillions more. And within that immense and steady progression, this moment is safe. This night is quiet. The stars remain distant and steady. The darkness remains vast and peaceful. And you can rest beneath it, carried within a universe that moves slowly, calmly, and endlessly forward. And as the universe continues moving forward, there are processes unfolding that are almost too slow to perceive, even across cosmic timescales. Not everything dramatic happens in explosions or collisions. Much of the universe evolves through gradual shifts in temperature, density, and distance. Consider the way galaxies age. In their youth, galaxies are rich with cold hydrogen gas, the essential ingredient for star formation. Over time, that gas becomes locked inside stars or heated by energetic processes near galactic centers. Without fresh material, star birth slows. A galaxy that once shimmered with bright blue stars gradually becomes dominated by older, redder populations. Astronomers sometimes refer to these as red and dead galaxies, though even they are not truly inactive. They continue orbiting, interacting gravitationally, and evolving slowly in structure. Within galaxy clusters, enormous reservoirs of hot gas fill the space between individual galaxies. This gas emits faint X-rays, detectable only with sensitive instruments. The presence of such hot plasma tells us that clusters are not simply collections of stars, but dynamic systems shaped by mergers and gravity over billions of years. Even at these immense scales, energy redistributes itself gradually, moving toward equilibrium. If we narrow our focus again to individual stars, we find rhythms that mirror the larger universe. Stars pulse gently in brightness. Some expand and contract slightly over predictable periods. Others rotate slowly, carrying starspots across their surfaces much like sunspots on our own sun. Stellar winds carry particles outward, forming protective bubbles around planetary systems. Our solar system itself exists within such a bubble, called the heliosphere. It shields us from some high-energy particles drifting through interstellar space. Beyond that boundary lies the interstellar medium, a sparse mixture of gas, dust, and magnetic fields. Even there, space is not truly empty. A few atoms per cubic centimeter are enough to shape large-scale structures over time. Beyond interstellar space lies the intergalactic medium, even more rarefied. Yet it too contains matter, faint filaments of hydrogen tracing the cosmic web. Through careful observation of distant quasars, astronomers detect subtle absorption lines that reveal the presence of this nearly invisible material. These delicate threads remind us that the universe is woven together, even where darkness appears absolute. Space is structured, though softly. If we imagine a photon emitted from a distant galaxy billions of years ago, we can trace its journey. It travels through intergalactic space, passing clusters and voids. Its wavelength stretches as the universe expands, gradually shifting toward redder colors. Eventually, if aimed precisely enough, it may enter our galaxy, pass through our atmosphere, and be captured by a telescope mirror. That single photon carries with it a fragment of ancient history. Light is our messenger across cosmic distance. Without it, the universe would remain unknowable. Yet light itself moves quietly and consistently, never rushing, never hesitating. As expansion continues, cosmic distances increase. Two galaxies separated by 1,000,000 light-years today may be farther apart tomorrow, though the change is imperceptible on human timescales. Over billions of years, however, these incremental expansions accumulate, reshaping the large-scale map of the cosmos. Some physicists consider even deeper questions about the fabric of reality. Is space-time continuous, or is it made of discrete quantum units at unimaginably small scales? Are there additional dimensions beyond the familiar three of space and one of time? While such ideas remain theoretical, they illustrate how much remains to be understood. Still, despite these open questions, the overarching behavior of the universe appears remarkably coherent. It evolves according to measurable principles. It expands at a quantifiable rate. It cools predictably. Temperature itself tells a story. The cosmic microwave background currently measures about 2.7 degrees above absolute zero. In the early universe, temperatures were billions of degrees higher. As expansion continues, the background radiation cools further, becoming increasingly faint. Cooling is not sudden. It is steady. A slow drift downward across billions of years. Time also plays a central role in shaping cosmic perception. To us, years feel long. To stars, millions of years pass like moments. To galaxies, billions of years are part of a single rotation. The universe measures duration in expanses that stretch far beyond immediate experience. Yet there is symmetry in these scales. Just as galaxies evolve slowly, so too do mountains erode, forests grow, oceans circulate. Earth itself changes gradually, shaped by plate tectonics, weather patterns, and biological processes. Above it all, the night sky offers continuity. Even as stars are born and die, the overall appearance remains stable across centuries. Only careful measurements reveal subtle shifts. If we travel far into the distant future again, we can imagine the era of degenerate matter. After most stars have faded, white dwarfs, neutron stars, and black holes may dominate. Occasional collisions between stellar remnants could produce faint flashes of energy, but such events would be rare. Proton decay, if it occurs as some theories predict, would gradually dissolve ordinary matter over extraordinarily long timescales. Atoms themselves might not be eternal. Even the building blocks of matter may eventually transform. Black holes, once considered permanent, are predicted to emit Hawking radiation, an extremely slow leakage of energy caused by quantum effects near the event horizon. For stellar mass black holes, evaporation would take far longer than the current age of the universe. For supermassive black holes, the timescale is even greater. Eventually, perhaps after 10 to the power of 100 years or more, even the largest black holes could fade away, leaving behind thin radiation dispersed across expanding space. The universe would approach near maximum entropy, where energy differences are minimal and large-scale structure no longer changes significantly. Such projections lie almost beyond comprehension. Yet they emphasize a central theme: the universe transforms slowly, guided by consistent laws. Back in our present moment, we are fortunate to inhabit a time rich in structure and light. We observe nebulae glowing softly where new stars ignite. We measure exoplanets orbiting distant suns. We detect gravitational waves rippling gently through space-time. Each discovery adds another layer to the cosmic narrative. And yet, despite human curiosity and technological advancement, the universe itself remains quiet and indifferent to observation. It does not require recognition to continue unfolding. If you imagine rising gently above Earth's atmosphere, the view changes gradually. First, clouds thin. Then the curvature of the planet becomes visible. Beyond that, stars shine against a deep black background untouched by atmospheric scattering. The darkness becomes pure. Drifting farther outward, Earth shrinks into a small blue sphere. The moon orbits steadily. The sun glows softly, one among billions within the Milky Way. From beyond the edge of the solar system, our entire planetary neighborhood fits within a small region of space. The heliosphere blends into the surrounding interstellar medium. Beyond that, the galaxy's spiral arms sweep outward in luminous arcs. Zoom out again, and the Milky Way becomes one faint structure among many in the local group. Continue outward, and the local group blends into larger cluster patterns. At every step, scale increases, yet motion slows in perception. The larger the structure, the slower its evolution appears. This pattern offers calm reassurance. Nothing sudden disturbs the largest scales. The universe is governed by balance, gravity pulling inward, expansion pushing outward, fusion generating light, radiation carrying energy away. These balances maintain stability across immense spans of time. And tonight, as stars continue their fusion cycles and galaxies continue their slow rotations, you remain here beneath the same cosmic canopy that has existed long before humanity and will exist long after. The universe does not hurry toward its ending. It expands gently. It cools gradually. It transforms steadily. Even as we explore theoretical futures and unimaginable durations, the present remains simple. Space stretches. Light travels. Matter interacts. Time advances. Above the horizon, stars shine at their own steady pace. Some are closer, their light recent. Others are distant, their light ancient. Together they form a tapestry across the night. Within that tapestry lies continuity stretching back nearly 14 billion years. There is comfort in that continuity. No abrupt changes. No cosmic urgency. Only the slow unfolding of physical law. If thoughts drift, let them drift gently across those distances. Imagine moving through the cosmic web, gliding between galaxies, passing through quiet voids where darkness is complete yet peaceful. Imagine the faint glow of distant clusters shimmering softly in the distance. Imagine time stretching outward as smoothly as space itself expands. The universe has always moved slowly. And you can match that rhythm now. Slow breath. Slow thought. Slow awareness. Beyond Earth, beyond the solar system, beyond the Milky Way, expansion continues with calm persistence. Stars burn steadily. Galaxies rotate gracefully. Black holes sit silently at their centers. The cosmic background radiation continues cooling almost imperceptibly. All of it steady. All of it patient. As this journey extends across distances and epochs, there is no demand placed upon you. The cosmos carries itself. It has done so for billions of years. It will continue for trillions more. And within that immense and gentle progression, you can allow your mind to quiet. The universe does not need to be solved tonight. It doesn't need to be measured fully or understood completely. It simply needs to continue. And it will. So as galaxies drift farther apart and ancient light continues crossing the dark, you can rest within the knowledge that everything moves according to steady principles. Gravity shapes. Expansion stretches. Energy flows. Time passes. And the universe expands softly into the vastness, carrying with it stars, galaxies, and you, all moving together through space and time. There is no urgency in infinity. Only calm extension. Only quiet persistence. Only endless continuation. And as it continues, you can drift peacefully beneath the same vast sky that has always existed, and will continue existing, long into the silent future.